Good day everyone. So let me discuss to you the part 3 of chapter 14, quality planning in project management. So several different tools and techniques are available for planning and controlling the quality of a project. The extent to which these tools are used is determined by the project complexity or the difficulties and the quality management program in use by the client. So the following represents the quality planning tools which are available to the project manager. First is the cost-benefit analysis. This is looking at how much your quality activities will cost versus how much you will gain from doing them. The costs are easy to measure, but the effort and resources it takes to do them and are just like any other task on your schedule. So, this is the first technique in quality planning wherein we are going to look for the cost of the quality activities versus how much you will gain or how much you will benefit to the project or the quality of your activities. Since quality activities don't actually produce a product, it is sometimes harder for people to measure the benefit, and the main benefits are less reworking, higher productivity and efficiency, and also more satisfaction from both the team and the customer. Next is the benchmarking. This means using the results of quality planning on other projects to set goals for your own. For example, you might find that the last project in your company had 20% fewer defects than the one before it. So you should want to learn from a project like that and put in practice any of the ideas they use to make such a great improvement. So benchmarking can or will give you some reference points for judging your own project. Kumbaga, you are going to have an evaluation to your own project before you start the working. After benchmarking, design of experiments. It is the list of all the kinds of tests you are going to run on your product. It might list all the kinds of test procedures you do, the approaches you'll take, and even the tests themselves. In the software world, this is called test planning. Next of this is cost of quality. It is what you get when you add up the cost of all the prevention and inspection activities you are going to do on your project. It doesn't just include the testing, it includes any time spent writing standards, reviewing documents, meeting to analyze the root causes of defects, reworking to fix the defects once they're found by the team. In other words, absolutely everything you do to ensure quality on the project. Cost quality can be a good number to check to determine whether your project is doing well or having trouble. When your company tracks the cost of quality on all of its project, so masasabing you are spending more or gumagastos ka ng malalaman mo na gumagastos ka ng malaki or mababa than has been spent on the other project to get your project up to quality standards. So this is the cost of quality. After the cost of quality, let's proceed to control charts. Control charts can be used to determine or define acceptable limits, and if some of the function of a project are repetitive, statistical process controls can be used to identify trends and keep the processes within control limits. For controlling the quality of repetitive process, part of this is to determine what the control limits are and how the process will be sampled. So you are going to do a control charts for you to identify or define the acceptable limits if some of the function of your project has a repetitive process. Next is the cause and effect diagrams. These can help in discovering problems of the project. When control charts indicate an assignable cause for a variation, it is not always easy to identify the cause of a problem. Discussions that are intended to discover the cause can be facilitated using a cause and effect or a fishbone diagram, where participants are encouraged to identify possible causes of a defect. As an example, diagramming quality problems. A small manufacturing firm tries to identify the assignable causes to variations in its manufacturing line. They assemble a team that identifies 6 possibilities, as shown in the fishbone diagram in the next slide. You can see in the figure, these are the 6 possibilities that the team had identified, which this is the assignable causes to the variation in its manufacturing line. Number 1 is the low quality raw materials, power fluctuation, ambient temperature, worker absenteeism, poor training, old equipment. And these 6 possibilities had a major defect. Each branch of the diagram can be expanded to break down a category into more specific items. An engineer and electrician work on one of the branches to consider possible causes of power fluctuation and add detail to their part of the fishbone diagram. As shown in the figure, the power fluctuation had its possible cause, which is the utility reliability, overloaded circuits, which are the large motor startup, and the personal space heaters, and also the lightning. And this possible causes turns into major defect. Check sheets, histograms, and Pareto charts are used to solve several quality problems. When a quality control issue occurs, a project manager must choose which problem to address first. One way to prioritize quality problems is to determine which ones occur most frequently. This data can be collected using a check sheet. Check sheet is a basic form on which the user can make a check in the appropriate box each time a problem occurs, or by automating the data collection process using the appropriate technology. This is the example of a check sheet. Once the data are collected, they can be analyzed by creating a type of frequency distribution chart called a histogram. This is an example of a histogram. Histogram is a column chart where the widths of the columns fill the available space on the x-axis and are proportional to the category values displayed on the axis, while the height of the column is proportional to the frequency of occurrences. Most histograms use one width of column to represent a category, while the vertical axis represents the frequency of occurrences. A variation on the histogram is a frequency distribution chart invented by economist Vilfredo Pareto, known as a Pareto chart, in which the columns are arranged in decreasing order, with the most common on the left and the line added that shows the cumulative total. So this is the example of a Pareto chart. The combination of columns and a line allows the user to tell at a glance which problems are most frequent and what fraction of the total they represent. So once you have your quality plan, you know your guidelines for managing quality on the project. Your strategies for monitoring project quality should be included in the plan, as well as the reasons for all the steps you are taking. It is important that everyone on the team understands the rationale behind the metrics being used to judge success or failure of the project. In quality assurance, the purpose of this is to create confidence that the quality plan and controls are working properly. Time must be allocated to review the original quality plan and compare that plan to how quality is being ensured during the implementation of the project. This is the quality assurance, which the quality plan and controls must be assured to have an assurance the project are working properly. Of course, when we are doing a project, we must have an assurance that the project or our project have its own quality. Siyempre, kung sigurado ka naman sa ginagawa mo o sa mga gagawin mo, sa mga ginagawa mo, siyempre meron kang confident or you are confident to show that your projects are working properly, di ba? So, let's proceed to the process analysis. The flow charts of quality processes are compared to the processes followed during actual operations. If the plan was not followed, the process is analyzed and corrective action taken. The corrective action could be to educate the people involved on how to follow the quality plan, or it could be to revise the plan. Kapag ang plano sa isang project ay hindi nasunod, of course, you are going to analyze it and take an action. Pupwedeng turuan ang mga taong involved doon or yung mga taong kasama doon sa project na sundin kung ano man yung mga plano dun sa project, or it could be to revise the plan itself. Because projects are temporary, there are fewer opportunities to learn and improve within a project, especially if it has a short duration. But even in a short project, the quality manager should have a way to learn from experience and change the process for the next project of a similar complexity profile. An example of this is analyzing quality processes in safety training. A technical college responsible for training employees in safe plant practices evaluates its instructor selection processes at the end of the training to see if it had the best criteria for selection. For example, it required the instructors to have master's degree in manufacturing to qualify as college instructors. The college used an exit survey of the students to ask what they thought would improve the instruction of future classes on this topic. Some students felt that it would be more important to require that the instructors have more years of training experience, while others recommended that instructors see certification at the training center. The college considered these suggestions and decided to retain its requirement of a master's degree but add a requirement that instructors be certified in plant safety. The purpose of quality assurance is to build confidence in the client that quality standards and procedures are being followed. This is done by an internal review of the plan, testing, and revision policies, or by an audit of the same items performed by an external group or agency. Tulad sa ating school or sa ating university, from the recent accreditation of ISO 900, that is to ensure that the quality of our university or our institution, they are standard met the customer satisfaction and maintain the efficient quality system ng ating university or ating school. So yun. That's all, guys. Thank you for listening. Hope you enjoyed the learning and God bless.